Hey guys, today I want to answer the question, what is E? Some of you might already be familiar with the regular definition of E, which is a limit, and that makes sense. But what if we're wondering about other definitions of E? Are there definitions that we haven't seen or encountered before? In this video, I want to talk about a randomized definition of E. Or if I'm being more precise, a probabilistic definition of E. In order to get where we're going with this, we need to think about a uniform random variable. That's a random variable that can take continuous values between 0 and 1. For example, it might be here, or it might be there, or any number of places between 0 and 1. The critical thing about a uniform density is that it is uniform. And in particular, for a random variable between 0 and 1, the density equals 1 for every point in that interval. What we're going to need here is a whole sequence of random variables, all of which are uniformly distributed between 0 and 1. In particular, we're going to need infinitely many of them. So we'll define x1, x2, all the way up through x infinity, all of which are uniform random variables. How does this relate to E, you might ask? Well, to answer that, we need to define another random variable, v. And v will be the minimum number of the x's, which are all uniform between 0 and 1, that we would need to add together before we get a number greater than 1. Now here's the important part, guys. In order to get E, we need to look at the expected value of v, where the expectation is taken over all of the randomness in all of the xi's. And in particular, this expectation equals E. Isn't that crazy?